Swayam Prabha. Digital India. Educated India.
We have defined the planar circuits and meshes. Now we will carry out mesh analysis, and the first type of circuit we will take will be circuits with only resistors and independent voltage sources. You can see that this is sort of the counterpart of nodal analysis, where we first took circuits with only resistors and independent current sources. That happened to be the most convenient case for nodal analysis. Similarly, for mesh analysis, the circuits with resistors and independent voltage sources are most convenient. Okay. Let me take a particular circuit. And let me label these B1, maybe R1, 1, R13, R12, R23, R22 and R33. Okay. And I label that V2. You can clearly see that there are three meshes. One is here, another is there, and another is over there. So with planar circuits, identifying these things is very easy. Okay. Now what I'll do is I'll define current variables. These are known as mesh currents. Okay, and by convention I'll take these currents to be flowing in a positive direction. So let me call this mesh current I1. I'll explain what they mean. And this mesh current I2. Okay, and this one as I3. Okay, now what does it really mean? So I'll take each mesh, and in that mesh I'll identify a current. Okay, now what is this? The branch currents are related to these mesh currents. Okay, so if a branch belongs to only a single mesh, such as this R11 and V1, which belong only to this mesh number 1, then the current through these is equal to the mesh current. Okay, so the mesh currents are clockwise currents identified with each mesh. Okay, now the currents in the branches if the branch belongs to a single mesh, then the branch current equals the mesh current. Let me identify those. So current through R11 in this direction will be I1. We have not calculated the value of I1, mind you, that will come later, but I am only relating the current in each branch to mesh currents, I've already identified the mesh currents. Now I'll write each branch current in terms of those mesh currents. Okay. This is somewhat like taking node voltages and then relating voltages of each branch to the node voltages. Okay. So that is also I1, and here I2. You will take it in the proper direction. Current through R22 will be I2, and current through V2 will also be I2. Similarly, current through R33 will be I3 in this direction. Okay. Value of I1 and I2 and I3 will be solved for later. Now, if a branch belongs to more than one mesh, we know that a branch can belong to at most two meshes. The branch belongs to two meshes. Then the branch current equals the sum of individual mesh currents. Okay, and because you take all mesh currents to be in the clockwise direction, okay, basically in the same direction, what happens is that a branch can belong to two meshes, and the branch current will be the algebraic sum of I1, which is flowing downwards in R12, and I2, which is flowing upwards. It will always be like this. One of them will be flowing in one direction, the other one will be flowing in the opposite direction. So the branch which belongs to two meshes will have its current to be the difference between two mesh currents. Okay. For instance, the current through R12 will be I1 minus I2. The current through R23 will be I2 minus I3. The current through R13 will be I1 minus I2. Okay. So these are the branches which are common to more than one mesh. Okay, and their currents will be the difference between two mesh currents. Okay. Now you see also the analogy between nodal analysis and mesh analysis. In nodal analysis, the voltage across any branch will be either one of the node voltages. Okay, if the branch is connected between some node and the reference node, then the voltage across the branch will be one of the node voltages that you solved for. If the branch is connected between two nodes, neither of which is the reference node, then the branch voltage will be difference between two node voltages. Similarly, in mesh analysis, if the branch is on the periphery of the circuit, that is, if it belongs to only a single mesh, then its current will be equal to the mesh current, and if the branch belongs to two meshes, then its current will be equal to difference between two mesh currents. Okay. Now one difference though is that unlike node voltages, the mesh currents may not represent a current flowing anywhere in the circuit. What I mean by that is, node voltages you can always measure with a multimeter. That is, let's say you have a voltage between some node X and the reference node. You take a voltmeter and place it between node X and the reference node, and you will measure that voltage. Okay. Now if you have a mesh current, then that may not be any of the branch currents. That is, that current may not be flowing anywhere in the circuit, right? For instance, let's say I have a circuit like this, where I have a circuit whose graph looks like this. These are all nodes, but of course here I am concerned with currents. So let's say you take the current in the innermost mesh, and if you look at these four branches which enclose the mesh, their currents will not be equal to this mesh current. Okay, their current will be this mesh current minus some other mesh currents, like this one or this one or this one or that one. Okay. So this mesh current, if you see, you cannot measure this particular mesh current in any branch of the circuit. So in a way, it's like an auxiliary variable which may or may not be found in the circuit. If you have a mesh current belonging to an outside mesh, that is a mesh on the outside, something like this, then this mesh current can be measured by measuring that branch current. Okay, whereas for the red one, that's not possible. But as far as finding the solution to the circuit is concerned, these variables will work just fine, and we can go ahead with mesh analysis just like we did with nodal analysis. Okay, so I hope you have understood the definition of mesh currents. You of course take them always in the same direction, and by convention I'll take them in the clockwise direction. Okay, and from that you understand that every branch current is either equal to a mesh current or difference between two mesh currents.